Yeah. So today our topic of discussion is functions. Okay. Oh, sorry. Okay. So we will have two class on this topic, one now and one later. Why? Because I find some crucial topics in function is really important to be discussed in the advanced course. Okay. And what are those? Those are plotting how to like knowing how to plot the graph of a function first. Second is mapping of a function and some specific kinds of function like greatest integer function, fractional part of a number, something like that. Okay. So these topics I will cover later in our class, but today I will cover functions first of all. Uh, I will cover real number system a little bit. Real number system. Okay. And then I will move forward with relation. Okay. 3. Then definition of function. Then domain, codomain and range. And finally, I will do limit. Okay. And there are a few ways to solve the limit problem. So we will focus on the first the definition approach. Okay. Number 2, then we will go through the formula. Okay, like whatever basic formula we know, like factorization approach or basic approach. Okay. Then we will do sandwich theorem. Okay. And after that, we will do limits in 0 by 0 or infinity by infinity form. Okay. And finally, we will do in hospital. Okay. So we are going to cover a lot of topics. So I will move faster and I will solve a few examples. I have already given you the book which I will follow for this function topic. I would highly recommend to read that book specifically and to go through all the examples on your free time, because it appears to be that some of the exams tend to follow this book and they just state the questions directly from the book. So it's really beneficial if you read the book, and if you can read the book, then you'll be master in relations, okay, and functions. Okay. So this is the class plan. Now let me start with real number. Okay, so please be interactive in class. Like I will ask you some questions and I would give you some problems. You need to solve it and tell me the answer. Okay. First, let me tell something. Like, of course, you guys are from maths background, so you know that set of natural numbers are represented by this n. Okay, set of integers are represented by this z. Okay, and set of real numbers are represented by this, and set of complex or like not complex rational numbers are represented by q. Okay, but okay. So we know that a number system can be represented in a number line. Okay, so this is 0, and this part is something like, say, if we denote this number as x, so x greater than 0, x less than 0, and at particularly this point x equals to 0. Okay, so uh, I will just tell a few things like for your future reference, whenever we will start uh, probability and statistics, this will be required a lot. Okay, so if I want to consider an interval, how can I write it? And why do I want to write it like that? Okay. So say there is an interval from A to B. Okay. Whatever A and B belongs to, say, real number. Okay. So how can I write this? That X is a number in between this A and B. Okay. It's a set of number which is taking a value in between the range A and B. So we will write it in a set form. Okay. Set of X such that X in between A and B. Okay. This means that X belongs to in the open interval of A and B. X cannot be equals to A or equals to B, but it can take any other values in between A and B. Okay. But if we do something like, if we want to make it X belongs to closed interval A and B, if we want to include the A point and B point, then we will write it X belongs to X such that A less than equals to X less than equals to B. So this is how we write. Okay. And why this is important? Uh, in probability and statistics, there is a notion for discrete random variable and continuous random variable. Okay. So in case of continuous random variable, there is no point probabilities. Okay. So probabilities at point A and at point B or any some a particular point is not defined. Okay. It's called zero. So we assume in terms of density. So at this point of time, these two things are similar for continuous random variable. I will discuss it later. But for discrete random variables, these two things are really different. You need to consider equality concepts like A and B. But but if you want to find something like this, then you don't need to consider the point probabilities. Okay, so that is why I am mentioning. So okay, you know pretty much how this number line works, and or if you mix and match these things, like if you want to find X belongs to open interval A, closed interval B, or something, closed interval A, open interval B, you can do that. Okay. Now tell me one thing. How can you write this one? X belongs to minus infinity to plus infinity. What braces should I put?
Ma'am, we denote it by the R, the whole real number system.
Yeah, exactly. How, which braces do I need to put? Exactly. X belongs to real number. Then,
What do you want to know? It is a real
Ma'am,
number.
open
So,
braces.
yeah, exactly.
yeah.
Don't put closed braces whenever you will write minus infinity to plus infinity, because you don't know what is an infinity. That's why. Okay.
Okay.
There is an infinity after that infinity. I just wanted to know that. Yeah. So, yeah, this is fine. Like this takes all the values in the real range from minus infinity to plus infinity. Okay. So, yeah, so this is pretty much done. I just wanted to brush up this concept for future purpose. Okay. So in the book, in the next section, there is something on. There are a few problems on inequalities. So inequalities, I'm not going to cover. Schumann will cover inequalities. So probably he will give you some reference from there. You can read it from the. Okay. So now I will move on to our main topic, relation, and why I mentioned it like beforehand, like why this number system is important, because I want to formulate the domain and range in terms of the number system. Okay, fine. So relation. Yeah. So the relation is a set of ordered pairs. Okay. Relation is a set of ordered pairs. Someone wants to join. Okay. Which is a Cartesian product from a non-empty set A to non-empty set B. Okay. Like Cartesian products means A cross B. Okay. Say A can take a few values on like say A1, A2 up to AN, and B can take some values B1, B2 dot Bn. Then if you take the Cartesian product of this A set to B set, then you are going to get a relation. So that is, you can make A1, B1, A2, B2, or something like that, like A1, B1, or A2, B1 also at some point of time. Okay. And these are the ordered pairs. This is important. The ordering is important. Finally, you will get A and B and something like that. Okay. Then tell me one thing. If we do A cross B and if we do B cross A, are these similar?
No, ma'am. They are only
Why?
similar
Yes.
only pay to B.
Sorry.
They are similar if and only if A is equal to B.
Yeah. Exactly. They will be similar if A is equals to B. Okay. Otherwise, like your set will start from B1, A1. Okay. And you will go from every like 1, 2, 3, A, B, 1, 2, 3. So this, and this. Okay. So fine. This is just for like I'm not going deeper into relations because there are a few things like different types of relations. I don't want to uh, do it right now. But one important thing I want to discuss that is mm, yeah, one important thing I want to discuss, that is what is the range and codomain and domain. Okay. It's very clear from that a relation is a Cartesian product from non-empty set A to non-empty set B. Okay, A and B. So, of course, as it is an ordered pair, so this is the domain. Domain means the support of the how, like what values this A can take, and codomain, yeah, exactly. Set A. Set A is the domain, and this set B can take, if it can take any values, okay, say take real numbers, okay, that is the codomain. Like that is a bigger set, okay. But in these relations, probably B is restricted to say some -5 to +5, okay. But still it belongs to the R, but not the entire R set. So this thing we call, this is range, okay. This is pretty much similar for relations and functions as well. Like for functions, we also define it similarly. So if you want to find the bigger set of the range, that is the codomain. But if you want to find the exact range, then you need to give the exact support, like in which it is actually lying. Did you get my point?
Yes, ma'am.
Okay. Yeah. And you will do one things like in the next that lecture, like another function lecture, that how many relations mappings are possible, okay, like 1 1 1 2, those are mainly combinatorics problems, but that is where we can relate uh, calculus to combinatorics at some point of time, okay. Those are counting problems, not today. Today is not the goal. So now I will move on to the main thing, function, okay. And we will start solving a few problems from this one. Just excel. Okay. So what is function? Function is also a special type of a relation. Okay. This is special type of a relation. Special type of relation. Okay. And what is that? A function from set A to set B, we call is a relation F. Okay. Set B. Okay. Such that from A to B, A is the domain and B is the codomain or range in this situation, such that it holds a property that, very important, you need to understand it a lot, like for every element in set A, okay, or you can write it in this terms. For every element A in set A, okay, has an image uh, has an exactly one image, not exactly one image in set B. Yeah. Set B. So how can we write it mathematically? Okay. So mathematical definition is, for every element in set A, there exists one and only element B in set B such that A comma B belongs to F, or such that uh, F of A equals to B. Okay. So what does it mean? You have a set of A, you have a set B. Okay. And you are trying to define a function F in between them. Okay. So for every element in A, like every element in A, there exists only one unique element in B. Okay. Like A can go from this element to this element, then none other element in A can go to, yes. But this A can't have another image in B. Okay, like this cannot happen. But this is allowed. Two elements can go to a same element. And what is the example? This is y equals to x square. For x equals to plus 1 and minus 1, y equals to 1. Or same for all the pluses and minuses. Okay. This is permissible, but this is not. Like one element in A can have one and only image in set B, not two images. Okay. This will be much more clear when I will explain one-to-one mapping, bijection, many-to-one mapping, everything. Okay. But please remember this thing, because, and then tell me one thing, like, is it a function? This is an equation, of course, like you know, it is circle. Yeah,
No, ma'am.
this is not a function. Okay. Because yes, like for like two values of x, we can get a single y. Okay. No, for sorry, one value of x, we can get two single y's. Say this one. So this is not a function. And same thing goes for parabola as well, ellipse as well. Okay. So you need to be careful. These are not functions. Okay. Fine. Yeah. Uh, yeah. Normal variations. Yeah. So I will define a few set of functions, like different types of function, what it can be, just terminology basically. So there is something called constant function. And what is that? If belongs to, like, if is from real to real, and y equals to f of x equals to c. C is a constant. C belongs to R. Okay. Real number and is a constant. Okay. So what will be the graph of this function? Like, of course, the domain is real and range is also real, but y takes a specific value c. Okay. So this is this is c. Y equals to c. Okay. So this is the constant function. Next, I will move on to identity function. Okay. So what is an identity function? Yeah, that is something like, yeah, again, real to real. Y equals to fx equals to x. Okay. Any function of that element is giving you back that element. Okay. That is called the identity function. And what is the graph of this function? This is this with 45-degree angles. Maybe should- Yeah, yeah. Oh, sorry. Yeah, I did not. Yeah. Okay. Time was. Now, the point is that next functions will be uh, um, square function. Okay. And that is also a from, yeah, of course. Here, I need you something to do. Okay. R to R. Okay. And y equals to fx equals to, say, x squared. Okay. You know, this function is something like that. Sorry, wait. Yeah, perfect. So this is something like that. And yeah, of course, the domain is the real entire. Okay. But this is what I mentioned. This is codomain. But what is actual range?
The non-negative real numbers.
Yeah, exactly. That is R plus. Okay. Because, yeah, of course, you know that there is nothing like this function is not valid in the negative part of y. Okay. So it can take only value in this upper range. Where is the pointer? Okay. Yeah. So in this range. Okay. R plus, what is R plus U0? I could not get it.
Ma'am, union 0.
Okay, okay. Yeah, yeah. Okay, like if you consider that zero is not like I'm not going to that much theoretical thing here. Okay, okay, fine. And now coming to the point of cubic function, you guys know, like need to know the graph of this nuclear function so that you can get an intuition whenever you need to draw the graph of a very complex function on your own. And it's very useful to find a graph by looking into one equation. Okay, so for here again the domain is R and the range is R because there is no restriction, and this is also, you know, this is what function symmetric to the exactly origin, and this is symmetric to y-axis, the square function. Okay, or the even function it is called. I will come to that point sooner. So what is the solution? Okay, so this is like this. Okay. Okay. And two more functions in very short. One is called, now I'm not going to write it in that detail. Yeah. So again, R2, R function is y means fx is 1 by x. So you know this function is something like this. Okay. So tell me about the domain and range.
Ma'am, domain is R minus 0
Yeah.
and the
Range is also r minus 0. It is undefined at point 0. It is infinite. That is why it is going to plus infinity and minus infinity. Okay. So of course, the from this, that is why graph is very important. If you can draw the graph, you can like really tell about the continuity and discontinuity about the graph. Okay. So this function is also done. And finally, I will do modulus function. Okay. And that is also a from real to real. And y equals to fx equals to mod x. And you all know the graph of mod x, which is very nice graph. Okay. We can do the magic again. Yeah. Okay. So this is the function. And again, the domain is real. And range is r plus and also plus 0. Okay, because it is also making the function. And by the way, there is a great definition of this function. So mod x equals to x when x greater than 0. Mathematically we write it like that, minus x when x less than 0. Okay, this is the definition of mod x. So whenever you will get something under mod, then you need to consider these two cases for drawing, for analyzing the function. Okay. Yeah, so this is also done.
Here, sorry, here like
Hmm?
if we take y as plus 1 also, we will get 1 same. There will be like 2, which you mentioned in the starting, right? Like from A to B, there should not be two relations, right? From the same point. If I take y as plus 2 also, I will get in x 2. And if I take y as
No,
minus
no.
2 also.
Yeah, that is okay. But for 2x, you can't, like for 1x, you can't get two values. Say x equals to 1, this is 1. For x equals to 1, you can get this. Do you get my point?
Yeah.
This is not okay. But this is absolutely okay.
Yeah.
Okay. That
Yeah.
means like for one value of y, of course, like your two values of y, x is mapping to one single point of y. Okay. But for this example, this is not okay. Don't confuse, get confused. Like try to remember it in your own way, graphically or something like that. Okay?
Yeah, okay.
Like whatever thing I have shown it to you, A to B. Like, of course, two A's can go to a same B. That is called many to one mapping. Three A's can go to a same B, many to one mapping. Okay? But this can't happen. One A can't go to two. This is not a function. Not a function. Okay.
Yeah, got it.
Any question at this point? I'm not finding something. Just wait for a moment. Yeah. Yeah, I want to give you a problem now. And yeah. And one thing more important is that, like, there is something called piecewise function. Okay. What is piecewise function? It is important to know the name, because even if CMI will give you the definition of a piecewise function, but sometimes in exam you might be intimidated to look into these jargons. So it's better to know what is a piecewise function. So piecewise functions means we write a function, say if t equals to something in a second bracket, basically. Okay, it is nothing except these things, like t plus 1 when t is less than equals to 0, say t square when t is greater than 0 and less than 1, okay, and say t plus 2 when t is greater than equals to 1. Something like that. I have defined a random function. I have no idea what this function is, but this is a piecewise function because we know that in this line range at 0, like less than equals to 0, at this point of time, it is following the t plus 1 equation. Okay. And after that, from 0 to 1, it is following t square. Okay. And then it is following t plus 2. So usually what is t plus 1? For t equals to 0, y is 1. For y, like if t equals to 0, y minus 1. Okay. Yeah, this is something like that. So yeah, this is the equation. And for t plus 2, it will be shifted. So something like that. And yeah, and it will be from okay. Oh, sorry. For something like that, it will be something from here as well. Not this. Yeah. This is the weird function, whatever I have written here. Okay. I didn't think much about the function. This will be, the graph will be something like that. I will teach you how to do it. Okay, so basically this function is called the piecewise function. And now we will solve one very interesting problem. Okay, to give you an intuition how to tackle those kind of challenges. Okay, so we have an fx equals to x cubed x less than 1. Okay, and it is 2x minus 1 x greater than equals to 1. 3x equals to 3x x less than equals to 2 and x square x greater than 2. Then what we need to find? We need to find f minus g of x. Okay. So you guys will do this and tell me the answer. But I am going to give you one hint. Check the conditions. Okay. That means like you know the value of fx for x less than 1 and you know the value of gx, like not value, the function of gx for x less than 2. So there is an overlap in the interval. So how many new intervals you are going to get whenever you will do f minus g of x? You need to figure that out first. Okay. And then you can do this mix and match in that same interval. Okay. Like say, just one example. Okay. So this is 0. X is less than 1. Okay. So this region. And you know x is less than 2 for 3x. So for this region, your for x less than 1 in your region, this will be x cubed minus 3x. Okay. And another one I'm going to give. And then the next region, of course, whenever x will be greater than 1, but less than 2, it will be 2x minus 1. Yeah, less than equals to 2, greater than equals to 1. It will, the f will take this value and g will be 3x. Okay, and solve the rest too. And tell me. Solve the rest of this too and tell me the answer. Let me get some water. Minus x square minus gx, yeah. Right. Hmm. Yeah. Yeah, for let me do it then. For x greater than equals to 2, yeah, there is nothing left. So for x greater than equals to 2, your fx will remain 2x minus 1, but your gx will change, not equals to 2, because already we have considered the equality there. So x greater than 2, and that is minus x squared. Yeah. Yeah, just check. I am not quite getting it because uh, this is not, yeah. Yeah, fine. Okay. So something, if there is a function in this, in the braces, and it is really big, then you don't need to worry about it because this is nothing but a piecewise function. And you can break it down to the intervals, and according to that interval, this function will take different functions. Okay, or different values. Okay. I wanted to solve another example and wanted to ask you a question. Okay, so let me give you another question. I annotated the question, but I don't know what happened today. Anyways, so fine. Say S is a set of all the triangles. Okay. And A is the area of a triangle. Okay. A is the set of the area of the triangles. Okay. So we are defining a function from A to S. Is it a function? Palaniappan, what is your answer?
Ma'am, what is the definition of the function?
Yeah, I have mentioned now. Like from set of areas, we are trying to find the set of triangles.
A is a set, right? The area of the triangle of triangles.
Yeah, yeah. A is the set,
Then,
sorry, not set.
then ma'am, we have to know how you define the function. Other we can't say.
Yeah. Yeah, no is all right, but why? Why no? Give an example. Isha is right. And Chandranath, why can't you tell anything about it?
Because we do not know the definition of the function.
You do not know what?
The definition of the function. How we define the function, we do not know.
You are defining the function.
No, no, no,
You
no.
know how to find an area how to find an area from a triangle.
Yeah, half into base into height.
Then that is the function. Yeah, that is the function. You know how to find.
Oh, actually, you are mapping the area to the specific triangle of that area, right?
Yes, at some we are trying to map area of a triangle to the triangle.
Okay.
Yeah. I guess Autrolita Shaha answered it correctly in the chat. Be careful with these problems. Exactly. There can be many triangles with the same area. And this is what it is happening. Okay. Say we have area 10 for a triangle. Okay. And we know the function. We can definitely find the angle, what we call the edges. Okay. And if we solve these things, we can come up with many triangles which can have area 10. Okay, one simple example is half into, if we call base is 4 and height is 5, that will be a right angle triangle. Okay, 5 height, 4 base, then it is also 10. Now another one, half, you were taking it 2 and you are making it 10. This is also another triangle with area 10. Okay, so now this is the case like where you are finding, like this is A to S, okay? for same A, you are finding multiple S. Okay. So exactly A from A to S is not did you understand, Chandranath?
Yes, ma'am. My doubt is clear. Okay, ma'am. Got
Okay.
Yeah.
Palaniappan,
Yeah, got it.
you got it? You asked a question? Yeah. So, yeah. If you want to prove that it is not a function, give a counter example. That for this thing. Like if for a single value of A, you can generate multiple value of like in the codomain. Okay, if you can give the example, then your claim is like proof. Like, okay, it is not a function. Okay. I will mention this thing again and again. Whenever you want to prove a thing, okay, then you need to write it down. But when you want to disprove something, here I am disproving that it is a function, then one counter example is sufficient. Okay. That okay, for this counter example, this claim is not satisfied. So, okay, this claim is false. It is okay. Fine. So we did mostly covered things. Okay. Yeah, piecewise function is also done. Yeah, I'll give you one homework in that. Okay. Um,
Ma'am, what is the answer to the previous problem?
what is the
Answer of the previous problem, accurate answer.
which previous problem?
The f minus g of x, f minus gx.
I wrote it now. This is the
Okay,
answer.
ma'am. Okay, got it.
Okay. Okay. Now another problem for you. Solve it and tell me the answer. Fx equals to x square minus x plus 1 by x square plus x plus 1. Find the domain and range. Yeah. Find out the range. Why the domain is R, by the way? First, this is a like fractional function. Okay. So you have a numerator and a denominator. So you need to find a point in X, like in the domain of X, for which this function Y is not defined. Okay. Then what you need to do, you need to equate these things with 0. If you can find anything in that real domain, okay, say, but this thing doesn't have any real solution. Okay. You can't write it because you know the discriminant. Use your knowledge from the quadratic equation, solving quadratic equation, Sridharacharya's system, minus b plus minus b square. What is b? It is 1 minus 4a and c by 2a. 2 into 1. So this is minus 1 plus minus minus root 3 by 2. So it has complex roots. I root 3 by 2. Okay. So it has complex roots. So of course, so for in real domain, you can't find any value of x which will make your denominator 0. Yeah, exactly. Isha and Sandra, both of you are correct. Okay. But you need to find the range. I'll give you 5 minutes of time. Yes. How many times? Yeah. What's the discussion is about? Avinav is saying, Sandra is saying it is R. Not exactly. And y is greater than equals to minus 1. Yeah, Chandranath and Akralita, both of them are seeing the same thing. It is correct. And yeah, closed interval is also correct. Isha, why are you saying that it is 0 to infinity? What's your reason behind it?
I thought that x square plus x square minus x plus 1 is less than x square plus x plus 1. So I'm not
Why 0
sure.
then? Why 0? Can't it take any value in? Yeah, of course. Okay. Okay. So let's solve this problem. By the way, I want to know your approach, Chandranath and Atralita. How did you solve it?
Ma'am, the domain is quite easy. So I will. Can I tell the range?
Yeah. Yeah, I want to know the range because I already gave you the answer for domain.
Okay. The ma'am fx is equal to 1 minus 2x by x square plus x plus 1. We got the from. Then we divided it by x. Can you get me?
Hello, you are not audible. Yeah.
Can you get me, ma'am?
No, no.
Hello, ma'am.
Yeah. Tell me the solution again.
Actually, ma'am, fx is equal to x square plus x plus 1 minus 2x by x square plus x plus 1. Okay.
Okay. Yeah. That's okay. Fine.
Equal,
X
equal to 1
square plus x.
plus 1
Yeah.
minus by x square plus x plus 1.
Yeah.
You got the yes, ma'am.
Fine. Yeah.
Okay, ma'am.
Then.
If x not equal to 0, then we divided by x equal to 1 minus 2 by x plus 1 by x.
Yeah. Yeah. Exactly.
Now, ma'am, there is whether x greater than 0 or x less than 0. If x greater than 0, then x plus 1 by x जो minimum value होगा वो 2 होगा. मतलब x plus 1 by x greater equal to 2 if x greater than 0.
Okay.
And if x less than 0, then plus 1 by x less than equal to minus 2.
What?
If x less than
I didn't
0,
get it. Hmm.
then x less than x plus 1 by x less than equal to minus 2.
X plus 1 by x less than equals to minus 2. Yeah.
Then, ma'am, we get the from x plus 1 by x less than equal to minus 1.
Yeah. Less than equals to minus 1. Then.
Then we get
Less than equals
then
to minus 1.
2 by x plus 1 by x
Tell me.
greater equal to minus 2.
So then equals of course equal to minus 2 plus 1. Okay. Plus 2 plus 1, I guess. It will be actually less than equals to at some point. Yeah, of course. It will change the inequality. Plus 2 plus 1. It is coming the upper bound 3.
3.
And what
And
about the lower bound?
we get this x less than 0. If we get x greater than 0, then at the same way we get the lower.
Okay. And Isha, the Australita, how did you do?
I've equated the equation with y and then multiplied the denominator on the right side, and then I have done
Yeah.
discriminant more than equal to 0.
Yeah, exactly. Yeah. Yeah. This is fine. Okay. So, Anurag, whatever you did, you thought a lot about this problem. Okay. Uh, this is good, definitely, how you did. But also, one thing we can do is y equals to x squared. Of course, this is the thing, x squared plus x plus 1. Okay. So, what we can do, yx square plus yx plus y equals to x square minus x plus 1, and we can take them together, make it y anything. 1 minus y of x square minus 1 plus y of x plus 1 minus y equals to 0. So this is a quadratic equation. You can solve it for x using Sridharacharya minus b plus minus, or else you can do one thing like discriminant, yeah, minus b plus minus like b square, sorry. Discriminant is b square minus 4ac. B square minus 4, 1 minus y into 1 minus y. Okay, this should be greater than or equals to 0. You know that. So that is 1 plus y whole square minus 4, 1 minus y whole square. Okay, that is greater than or equals to 0. So this is the a square minus b square form. 1 plus y
Excuse me, ma'am.
minus 2. Yeah?
Hello. Ma'am.
Yeah, Vinay,
Hello,
tell
ma'am.
me.
Yes, ma'am. How do we know that the above equation is a quadratic equation?
Above equation is, oh, yeah, because you are getting a form ax square plus
Yes, ma'am.
bx
But
plus
ma'am.
c equals to 0.
But ma'am. How do we know that a is not equal to 0?
Yeah, if a is 0, then what is the problem?
Ma'am, if a is 0, then it is not a quadratic equation. Then we can't apply. We can't find discriminant, ma'am. Then.
No, why you can't find discriminant? If a equals to 0, then this term is gone. You just have bx plus c. So x equals to minus c by b. There is a simpler
Then, ma'am.
solution.
Yes, ma'am. Then we have to take both the cases in which a is equal to 0 and a is not equal to 0.
Okay, like you were telling that, okay, fine. You were telling me that if y equals to 1 in your case,
Yes.
then what will
Yes.
if y equals to 1 in your case, then what will happen? Okay.
Yes. Because ma'am, y can also take the value 1, and if we apply this quadratic formula, then we won't get y equals to 1. Then ma'am, we will be missing some range, a value in the range.
According to this formula, if y equals to 1, then yeah, then just this part is gone. Then this is the thing, I guess. Like if y equals to 1, then solve it like that, no?
There is no
Why
problem if
you are
y is
missing y? No, no problem. I can't see any problem.
x is equal to
If y
0,
equals
then
to 1, then x equals to 0. We are not missing out anything.
Of course, ma'am. Y will equal. We are getting also a value y equals to 1, and if we apply this discriminant formula, then we won't get this. We will be missing this value of y equals to 1 in that.
No, we are not.
Because ma'am, if we
Like,
are applying
okay,
this,
okay, like,
because if we are applying the discriminant formula, we are considering that y is not equal to 1. Then we also have to take the case if y equals to 1 and we are getting a real x for that, then it means y can also take the value 1, and we have to add that value.
Ma'am, if y is equal to 1, it's still a quadratic
Wait,
equation. Isn't it? The quadratic equation.
wait. Let me solve your query.
Ma'am,
Yeah,
so ma'am, as Abhinav was saying, if we put y is equals to 1, the x square equation will be terminated, right?
yeah,
And
exactly.
if we put y is equals to 1, then we get the value of x is 1 by 3 in that equation. X square would be terminated, and minus 3y plus 1 is equals to 0, and then y would be 1 by 3, right?
Yes.
So what I'm saying is, even if we solve for x, so we are getting the range 1 by 3 comma 3. So the range of x would be from 1 by 3 comma 3. So even if we put any value of 5, so we are finding a kind of a generalized equation to
No,
find the value of x.
actually in this question you will be getting the value y equals to 1 in the by only applying a discriminant formula. But they I have solved some questions in the past also, in which if we are not considering the case a equals to 0 and finding a real value of x, and we are not adding it into the final range which we have find through our discriminant formula, then it will the question will become wrong. I will share an example of that question. If you don't take a equals to 0 the case, then you will get a wrong range, you will miss a value. I have a example question also that I will share it in the group after that.
Ma'am, we can
Then,
think.
yeah, then let's do one thing. Like if y is not equals to 1, okay, say then we are getting a range of, like, after solving this, we are getting a range of 3 to 1, 1/3 to 3, okay. And then if y is not equals to y equals to 1 specifically, then for this example, this x square term will be gone, and minus of y equals to 1 means 2x equals to 0. So x equals to 0. Okay. So for x equals
Yes.
to 0, our y is 1, which is lying in between this range. So we don't need to consider anything else.
No, ma'am, what I'm saying in this particular question are y equals to 1 is we are getting the value through the discriminant also, but there is a question which I'll share in the group. If you don't consider the case if you don't consider the case a equals to 0 in the our quadratic formula, then we will be missing a value through the discriminant formula in the range. I have a counter question for that, which I'll be sharing in the group later when the class ends.
Okay. Minus x is not equals to x. Hence y not equals to 1 minus y equals to 1. Yes, share the link, okay? Like share the question in the group. I will have a look. Okay. But yeah, I need to think something about this one. But here, particularly in this problem, I don't see there is any problem. In this particular problem, if we solve both, including like y not equals to 1, then this discriminant analysis will be okay. And we can find 1/3 to 3 interval. And if we take y equals to 1, then also this quadratic term will be gone. Okay. And we can solve for other terms. Okay. You don't need to get confused. Now, as of now, you just do it likewise, and I will check whatever example is Avinav saying. If we can find another solution to that example, I will let you know. But this is quite generalized process of doing it. Okay. I will take a look after this class. But it's already 10:13 and I couldn't even reach to that point. Okay, I need to end the class within half an hour. Okay. So, yeah. Now I will go to limit and give you some sense of limit. So what topics we covered till now? Okay, we did real number system, relations, definition function, domain, codomain, range, just limit part is left. I will recheck this problem and I will tell if there is, and there is another solution Chandranath shared. We can also take that approach. And I was thinking, so I was somehow thinking to use the limit to find the range. I will also try to find if there is any other solution apart from this and why this is happening like that. Okay, let's mark this question. Okay. Now limit. I wanted to solve one more problem. Okay. Mm, okay. Say some homework problems. Just let me write it down. If x equals to 9 power x, 9 power x plus 3. Show that. No, I won't give you that. And evaluate. F of 1 by 1, 9, 9, 6 plus F of 2 by 1. Okay, this is one problem you need to solve at home. And this function as well. I will add them to the problem sheet, okay? F from R to R is an odd function, okay? Such that x square f of x. Okay. I will add more, okay? after this class. Fine. Fine. Okay.
Please
Okay.
show the last question once more.
Last question. Yeah.
Thank you, ma'am.
Yeah. Okay. Okay. So we have already known function. Okay. Later function is something like this. Okay. And there is something called a deterministic value. Like if x equals to say a, then the function will take a value, like may or may not take a value at y. Okay. Like in that case, whatever we have seen for 1 by x, the function is infinity at x equals to 0 at this point. Okay. But we can, whatever we can say, like in a very close interval of 0, like this function can reach to a very great, like huge, large value. Okay. So we can write it down, limit x tends to 0, 1 by x equals to infinity. Okay. So this infinity means, sorry, this infinity means this is a very large value. Okay. And okay, it might be some case like that. There is a function. Okay. Say at okay. Say at infinity, it takes value 3. Say a function is something like that, which is like that. It is taking a value of 3. Okay. So we don't know the value of exact value of x at which point the function will take a value of 3. But whenever the x is really large, okay, then we can assume that this function is taking a value of 3. So these things are called limit. Okay. So formally, limit h tends to 0, okay, f of x plus h, okay, yeah, can be something. Say this is a, okay. In the small neighborhood of x, it is approaching to a value of a. Okay. So it is important to know the approach from two sides. Okay. Like this h tends to 0 means it can approach from this side or from this side in a number line 0. So there can be something called 0.0001, or there can be something called 0.9999. Okay. And this is called x minus and this is called x plus. Okay. And this is called left hand limit and this is called right hand limit. LHL and RHL. Okay. So when you know that if limit exists or not. There is some function that for which limit does not exist. We have already have seen a few examples that where limit does not exist in the previous, like in the last part of our lecture. We will come to that point. And for limit, if limit h tends to 0 plus f of x plus h equals to limit h tends to 0 minus f of x plus h, then we can say the limit exists at a point x equals to a. Okay? If left hand limit and right hand limit exist at a point a, okay? Or say the like, okay, this is the, like, say, at any point, okay, x equals to x prime. Okay. Then you need to consider the left hand limit is equals to the right hand limit. Oh, you have already given me the answer of the previous question. This is your homework problem. You can't solve it now. Okay. Fine. Now for finding limit, those who already know limit really well, there is something called limit of a sequence, limit of a series, which is not required for CMI data science entrance exam. Okay. But sometimes they might give you a problem, and but you don't need to know the exact definition, and but you can find it something, some value or something. Okay. So let's solve a very basic thing. Okay. First, we will check if the limit exists or not. Okay. Let me take a function. Okay, by the way, you can write this again using this. Limit h tends to, this is also similar to this. H tends to 0, f of x minus h. Okay? And this is similar to this. Okay? Fine. So let's find this one. Usually, we try to define a limit at some point of time where the function is not defined. And we want to take a look that how in that region the function wants to behave. Okay. Otherwise, we have the functional value. We will use that. Why should we find a limit? Okay. So, if x equals to x squared minus 1 divided by x squared minus 3x plus 2 for x not equals to 1. So, you know that if you put x equals to 1, this is something called 0 by 0. You can't evaluate anything. It is undefined in terms of mathematics. Okay. But we are interested to know that at when x tends to 1 from both the sides, left hand side and right hand side, what can be the value is taken by x. Okay. So now what we will do, of course, we know that we need to check it at x equals to 1, and then we will find this limit x tends to 1 plus. Okay. How will we write this? That is equals to, let me write the function plus 2. That is equals to limit h tends to 0. Okay. Because 1 plus. So we will do it in terms of this. 1 plus x, h. Okay. H is positive, approaching from the right hand side. So 1 is a functional value plus h whole square minus 1 by 1 plus h whole squared minus 3 of 1 plus h plus 2. Okay. So after solving this, we are finding something called h squared plus 2h divided by minus 3 plus 2 is minus 1, and plus 1 will be cancelled out. Minus 3h and h square will be there, and 2h, so h square plus h, I guess. Yeah. This is the equation. Limit h tends to 0. Then it is h plus 2. H is getting cancelled out, and here it is h plus 1. Now this function is pretty much doable if you put h equals to 0. Sorry for the mess. Okay. And if you put h equals to 0, then it is coming 2. Okay. So this is pretty nice. From this form, we have transformed this in another form. This is what it is important. So this is the left-hand limit. What happened? Yes. And for 1 minus, for 1 minus, everything will be same, just h will be minus h. But why, whatever I have mentioned in the some time ago. Okay, we will see. Okay, so 1 minus h, 1 minus h, something like that. So,
Ma'am, that would be minus.
Yeah. What?
I think the answer is limit x tends to 1 minus fx is equal to minus 2. I think.
Oh. Did I make any mistake here? Mm-hmm.
Check second line.
Oh.
The
One.
denominator.
Yeah. H minus 1, I guess. H minus h. H square minus h.
And, how are we assuming that 1 plus h and 1 minus h, how is this transformation is happening, like from this one?
We're not assuming anything. Like, see, we want to find 1 plus. Okay. How can we write 1 plus? Like 1 plus, it will be something like 0 point, very small interval plus. Okay. So we are doing something like what we are just taking it as h, and we are taking that h is tending to 0 from the left hand side. This is the definition.
Yeah, okay.
Okay.
Now we get it.
Like what? Yeah, what I mentioned it here. See, whenever we do this thing, minus 0, h tends to minus 0, we do it minus h. And here for x, we are putting 1 because we want to find the limit at x equals to 1 exactly. That's why. Okay. So then solve it and it will also come -2. Okay. So yeah, exactly. We can find these two things like at x equals to -1 and x equals to +1. Both of these are coming to -2. So yes, limit exists. Okay. For this example, limit exists. But we can do one thing, like I just wanted to show you how the formula works. If something is there in terms of this, don't get worried, just keep solving it. Okay. But you can do one more thing here. Like basic thing you can do one thing to tackle this formula. Let me show you again, taking this example only. Okay. You can do one thing, you can factorize. So x square minus 1 means x minus 1 into x plus 1. Okay. And then you can factorize this. So this is x square minus 2x minus x plus 2. So x minus 1, x plus 1, now x minus 2 is one factor and x minus 2 is another factor. So this is cancelling out. So x plus 1 and x minus 2. Okay. Yeah. From here it is quite evident if you want to find limit x tends to 1. Okay. So if you put it 1, then it will be 2, 1 minus 2 minus 1, so it will be minus 2. So from here you can get the limit directly for 1. Okay. For solving it quicker, we don't really solve it likewise. This is just for an example. But for solving it quicker, we will first try to factorize. If we can get a form out of these two forms and which is not 0 by 0 form, and we can put the value of x in there. Okay. And also mentioning the L'Hospital thing, you can keep differentiating, okay, the numerator and the denominator till you are getting a form where you can put the value of not like of the form not 0 and 0. You can keep differentiating like that. Okay. So let's do that using L'Hospital. If x equals to like say like limit x tends to 1 fx. So this is 2x. This is again 2x minus 3. Okay. If you put x equals to 1, x equals to 1, yes, I guess you can pretty much get the form after just only one differentiation. So that is again 2, that is again minus 1, so it is minus 2. Okay. So L'Hospital is also easy in this sense. So first, of course, like for if you want to find a limit in terms of like a bigger problem, like in a bigger problem you want to find a limit in shorter way, then first try to find it in terms of factorize it, try to factorize it. If you can't, then go for L'Hospital. Okay. And now the main thing which I will cover, that is the sandwich theorem. Okay. And the limit formulas, you can get it from the book. Let me write down the page numbers. And yeah, and there is another thing I want to mention. Okay, for formulas, I will mention some thing. But now it's important to discuss the sandwich theorem a bit. Yeah, so let me find this limit. Limit x tends to 0, x square sine of 1 by x. One by x tends to 0 means 1 by x tends to infinity. Okay, x tends to 0 means 1 by x tends to infinity. And you know that sine is an oscillating function. Okay, at infinity it can take any value from +1 to -1. You don't know, really. Okay, then how you want to find the limit? Okay, so first thing what we know, we will write it down. We know that sine 1 by x lies between +1 to -1. Okay, and then we actually want to find something called x square. Okay, and now we will put limit. Okay, and we can see that both of these limits are going to 0 at x tends to 0. So as this function is less than this function and this is also converging to 0, then we can say that this function will also converge to 0, even if we can find it separately. Okay, Autrolita, in which you were saying does not exist?
I thought 1 by x tending to infinity, so we won't be able to judge sine 1 by x.
Yeah, exactly. That is the point. Na? Whenever something will be in this form, you don't really know. And for that reason, we are applying sandwich theorem to find such limits. Okay. What you need to do, if you can't find the lower bound, that is also okay. But if you can find the upper bounding function, okay, which is easier to calculate and which will be strictly like really greater than this function, and it is going to some limit, then this smaller function will go to that limit as well. So this is the sandwich theorem, intuitively. Let's solve one more example and it will be like easier for you to understand. There are many tough examples in this book, like you can go through. This will really help you to build your concepts a lot. So yeah, I will solve this. Yes. So this is actually limit of a series. We don't have this topic in CMI exam, but for the sake of sandwich theorem, I need to mention it. So we need to find the summation. Limit n tends to infinity, 1 by 1 plus n squared plus 1 by 2 plus n squared plus n by n plus n squared. So this is not a summation which you can calculate easily. You can't. Okay, because your numerators are also in arithmetic progression and your first term of the denominator is also in arithmetic progression. So what you can do, like whenever you will see a problem in this form, then you will think of sandwich theorem. I'm too lazy to write down the total name. So this is ST, sandwich theorem. Okay. So let's say it is Sn. So Sn is less than equal. So we are constructing a new series, which will be greater than this. So what can be greater than this? Any idea? Which we can compute very easily.
Ma'am, less than equal to n by 1 plus n square.
No.
Ma'am,
No, this is summation.
yeah, less than equal to 1 plus 2 plus dot 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 n by 1 plus n square. We can do that.
This one you were talking about.
Plus 1.
Yeah. But why are you doing that? Whenever you will say your answer, don't state the answer, state the procedure. Okay.
Okay. So numerator 1 plus n square is greater than all the denominators.
Exactly.
So
Yeah. You want to find something and you know that this numerator is also increasing. It is okay if you keep it constant. But if you can make something like denominator smaller, then this entire fraction will be bigger and you can find a greater series. So if we write it 1 by 1 plus n square, keeping this term intact, and we are making it 2 by not 2 plus n square, that is also 1 plus n square. So this term is bigger than this. 2 by 2 plus n square is smaller than 2 by 1 plus n square. Okay. And likewise, n by n plus n square is smaller than n by 1 plus n square. For the same reason, because this n is a big quantity, we are replacing it by 1. So our denominator is small and our entire fraction is large. Okay.
okay, ma'am.
So n by 1 plus n square. So Sn is less than equals to the normal summation 1 to n by 1 plus n square. You all know this thing. N into n plus 1 by 2, the AP formula, 1 plus n square. Okay. Now we need to put the limit n tends to infinity. I will also show you the this bound as well, but just wait. So if n tends to infinity, then we know 1 by n tends to 0. So here, if you can't put infinity at some point of time, so you need to make it in terms of 0. So that's why you divide it by n square, both. So n square means 1 plus 1 by n square divided by 2, 1 plus 1 by n square. Okay. So put it 0 or like, I don't care. Cross it at some point of time. Oh, made a mistake, not n square. N it will be. Because one n is cancelling out and by n. So you can't cancel it out. So you need to put n equals to 1 by n equals to 0. So this is coming as half. So your sequence will converge to half. This is sufficient. Like if we can find a series or something which is greater than the exact series you want to find, for our case it is Sn, and that converges to a limit to something, a value, say half in our case. So our Sn will converge to that point. It is okay. But also for the lower bound, you need to construct something which is smaller. Okay. Okay. So how can you make it smaller? Just the opposite idea. We took this first denominator to make it bigger. We will choose the last denominator to make it smaller. Just that thing, nothing else. So this smaller term we can write 1 by n plus n square plus 2 by n plus n square plus dot 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 n by 2 plus n square. Okay. So again, we are doing n plus n square, and we are taking the summation n into n minus, sorry, n plus 1 by 2. And again, we are doing the same thing for taking limit n tends to infinity, half 1 plus 1 by n divided by n will be cancelled out. Yeah, for this it will be again the same thing. Oh, for it will be again 1 by 1 plus n, so it will be also half. Okay? Any question about this problem? Ma'am, can you please explain once again? Yeah, exactly. Oh, by the way, n by 2, what is n by 2? Autrolita? No, ma'am. Okay. By the way, I might not check chat all the time. Okay, so please unmute yourself and talk. I won't mind at all. Yeah, exactly. Hina said, our main idea is that to find this limit, to find this limit, we need to find something which is greater than this and less than this, and which both of them converge to a same value. Then this limit will converge to the same value. Did you understand this point, Hina? Where are you? Unmute yourself. Hello, please. Yeah, if you don't mind. Okay. So for making one series on our own, okay, which is greater than this Sn, we need to find something bigger, and this is in the terms of numerator and denominator. So you know that whatever we have for all these things, if we can make the denominator smaller, then our entire series will be big. In this case, we know that just basic inequality. Okay. So 1 plus n square, not 1, like, say anything. Okay. N is big actually. Okay. N tends to infinity. Very big. So n square plus n is always bigger than 1 plus n square. You know this. Whenever you will do this reciprocal, your inequality sign will be reversed. Okay. So if you put this n and put something n, okay, so always this term will be bigger than this term. We are using this theory to construct a new series which will be bigger than our Sn. Did you get till this point? Okay. Okay. And that is how we constructed this series, which is bigger than this Sn. And we have shown that, yeah, it's really easy to calculate because we are having the same denominator. So we are just taking it common. And we are finding a very nice series, which is 1 to n summation. And you already know the formula. And so after calculating this and putting the limit of n to infinity, and eventually 1 by n to 0, you are getting half. Okay. So this is sufficient for you if you can find the bigger limit. Okay. But sandwich theorem also says that if you can find the smaller limit, and it is better to show that you are finding the both limits in which Sn can lie, and both of them are converging to a same value, then Sn will converge to a same value as well. Okay. And so constructing the smaller value, we are doing this. Instead of what were we doing? Like, we were just replacing all the denominators by this, the smallest denominator. For making it big, we will do the opposite. We will take the biggest denominator and put it for each and every value to make it smaller. Okay. We are doing like that. See, we are putting n square in for all the denominators to make the summation smaller than our original Sn. Okay. And this is also becoming very easy. So if we need to find two series, one greater and smaller, to find the limit. Yeah. Yes, it is advised. Yeah, it is advised to find two series. But see, if you are only finding the smaller series, that is not going to work. Okay. If you are finding the smaller series, then you also need to find the bigger series as well. But if you can find the bigger series initially, it is not needed that you need to find the smaller series as well. There is a theorem which I am not going to dig deeper into that. But for sandwich theorem, try to find both, smaller and bigger. Try to find both for you. But if you want to save your time, then you just focus on, like, for others or like who can understand this theorem properly, for them, just try to find the bigger series and try to find the limit. You don't need to construct a smaller series for that reason. Okay. So this was another example for sandwich theorem. And I guess that's pretty much I wanted. Yeah, and one last topic and one last example. We are already exceeding our time. Yeah. One last example. Sometimes nothing works. Nothing works means nothing works. You can find, say, factors. You can do also in hospital somehow. And you can't, like, you can't really get anything. So for that reason, it is really useful to use the series expansion of any function. I'm not sure if you are familiar with the Taylor series expansion or something like that, but every function has a series expansion. Okay? Like e power x can be written as 1 plus x squared by 2 factorial plus x cubed by 3 factorial, like that. E to the power minus x can be written as 1 minus x plus x squared by 2 factorial minus x cubed by 3 factorial, likewise. I'm pretty much sure that Shumon will teach you things like this expansion things in more details because he is taking the algebra part. And also we can find series expansion for log of 1 minus x. There is a formula, I can give it to you later. And sine x as well can be written as x minus x cubed by 3 factorial plus x5 by 5 factorial and so on. And cos x equals to 1 minus x squared by 2 factorial plus x power 4 by 4 factorial and likewise. Okay. So these are the series expansion of some special formulas. Okay. So if nothing works, limit x tends to 0 sine x minus x by x cubed. Okay. See here, also, I will share the list of the limits, like limit x tends to 0, sine x by x equals to 1. Okay. This is one very useful limit. Okay. So see, first we will try to factorize it. No, it can't be factorized. And also, like, x cube is there, so it's not useful. And then we will try to differentiate it. Let's say, like, see if it works or not. Okay. So differentiating sine x is cos x. And minus x will be 1 and 3x squared. Okay. And for again, we will differentiate because this is again the form. If we put x0, then cos 1, and x0, 0 by 0 form is still there. So we will do, it is L hospital, we are applying it, okay? Cos x is minus sin x. Minus sin x. Minus 1 will be 0. And 3x square will be 6x. Okay? But again, it is 0 by 0 form. And I'm tired to do that again. That is minus sin x is again cos x. And this is 6. Okay? And yeah, the L hospital is working in this situation. So if you put x equals to 0, then yeah, it is minus 1 by 6. This is the limit, you know. Okay. So if you want to find it like that, it's quite okay. It's working in this case. But if you can't find it, say, okay, you are not finding a 0 by 0 form after applying in hospital as well. So you can try out one thing. I'll give you one example of that as well. So for this, you can do one thing, like write down the expansion of sin x. That is equals to x minus x cubed by 3 factorial plus x5 by 5 factorial and so on minus x. Okay. And then x cubed here. Okay. So now you can cancel out this x and you can divide this function by x2 because this is an algebraic equation and it's easier to comprehend. So limit x tends to 0, this is minus 1 by 3 factorial plus x squared by 2 factorial and plus so on. And it's quite clear that if you put 0, all the next terms will be 0 and you don't care. So this is minus 1 by 3 factorial, which is 6. Okay. So this is really nice and I really love solving limits using series expansion because there is a problem which blew my mind off a few years ago. And from there, I have been a great fan of solving limits. And I didn't know that there was a theory in the book which exactly states that. I got the problem and I was struggling it for probably 2 days. I couldn't work on it. And then I found, okay, wow, we can do that. That's the idea. Okay. So, yeah, last example of today. Find the values of question. Find the values of A and B in order that limit x tends to 0, x at 1 plus b cos of x minus b of sin x divided by x cubed equals to 1. Okay, let me take it to the next page, I guess. Okay. So yeah, we find the values of a and b. We need to find two values of a and b in order to get this limit, like x tends to 0 and this will be equal to 1. Okay. Okay. So how can we do? So yeah, of course you can't factorize it. It's quite clear from here, like the upper part is some mixture of algebraic and trigonometric function and the lower part is algebraic function. Okay. And you can't do it. And even if you apply L hospital, let me apply and let me show you what is happening. So applying L hospital, taking x constant, applying this on it, that is minus a sin x. If I'm not wrong, yeah. Plus 1 plus a cos x. Okay. Minus b sin x will be cos x by 2x square. Sorry, 3x. Okay. Then again I am taking Checking again. Okay. So this is x minus a sine x. So that will be minus, and taking x derivative minus a sine x minus, again it will be minus. So taking x, a cos x, like ax cos x, a x is x, plus again we are doing that, 1 will be 0, minus a sine x minus b cos x will be plus sine x, something like that. Okay, it will be 6 of x squared, 6 of x, yeah, something like that. So if you keep continue to do this, you will arrive with at some point of time, you will arrive with something called a minus b equals to 1 or something like that. Okay, probably. If I'm not wrong, b minus a something 1 or something like that. I might not give you the exact thing. B minus a, yeah, this is the exact. If you do this, you will arrive at this condition that b minus a equals to 1. But from that, how can you infer that what is b and what is a? It can have, like, it is a straight line basically. And you can have multiple solutions. Like, actually infinitely many solutions.
Ma'am,
Okay?
from the second line, you can get another condition.
From second line, how?
Ma'am, the last line, as the limit is finite, then the numerator must be 0, right? Limit x tends to 0, numerator must be 0.
Why? This is 1. It is given.
Okay, ma'am. Okay, sorry. My mistake, ma'am. Sorry. I was thinking wrong.
Okay. Yeah. So you will end up with this. Yeah, I have solved this at least 10 times back then. So yeah, I remember it from there. It is pretty much b minus equals to 1. So from there, I was just struggling that, okay, I can find an algebraic equation from which I can get a relationship between a and b, but I can definitely find their two values. What can I do? Okay. So I am omitting these things because, yeah, I don't really need this for the notes. So what I will do, I will just straight away use the expansion. Okay. And the beauty of expansion is I will solve just 1 or 2 lines, not more than that. Then you will solve because it is a huge calculation which I don't want to do right now. So what is the expansion of cos x? If you don't mind, can anyone? Yeah.
Ma'am,
So,
ma'am, I am telling that
yeah.
in previous slide we got the last line, then we can apply L hospital rule again. Then we can get a equation which will be more easier, I think.
You apply. I have applied it 10 times.
Yes, ma'am. If the answer is a is equal to 5/2 and b is equal to 7/2.
Yeah.
Ma'am, I have applied. Then I got this.
You got this. Okay, you send me the solution later.
Okay, ma'am. Okay.
But it's recommended to do that. Like,
Okay, ma'am. Right.
I don't know, but I did that like lot of time and I couldn't come up with that solution at any point of time. Okay. So 1 plus a for cos, you can write it down 1 minus x squared by 2 factorial plus x 4 by 4 factorial, something like that. Okay. Minus b of Sine means x minus x cubed by 3 factorial plus x5 by 5 factorial, something like that. Okay? And here you are getting x cubed. Okay? And then you just solve it and tell me the answer next week. This is the hint and also the homework for the next class. Try both using L Hospital and this and tell me which one is easier or which one is actually solvable during the time of the exam. I'm not talking about the normal time. Yeah, someone might find a solution using L Hospital as well in the normal time, but you might get confused by doing lots of derivatives during the exam. But I guess this is the pretty easy and safest way to go like in the exam. I hope this is the way.
Ma'am, when I can understand that we have to use uh, uh, the functions derivation, I mean this type of form.
See, whenever you will try to find like that's the point of my discussion, na? I tried to find first the factors and then I tried to find uh, uh, do it using L Hospital, but it is also very difficult. Then I will go for the expansion.
Okay, ma'am. When nothing works, then I will try the expansion, right?
Yeah. When nothing works, then you can try expansion, but I prefer to do that in the like first hand.
Okay, ma'am.
I love infinite series expansions. Okay, so it's a really long time, so I don't want to like continue again more of it. Okay, so just okay. So I'll stop recording and thank you for attending my class. See you next week. Bye bye.